Let's pause and review. So for carbon, answer these 4 questions. Stop the video, answer them, and then I'll be back with the answers. Okay, we're back. So for carbon, what is the oxidation number for the family? So the oxidation number is a +4. For its family, all the electron configurations for the carbon family are going to end in p2. And write the electron configuration for carbon. So it's less than 10, so there's no abbreviation. It would be 1s2, 2s2, 2p2. It has 6 electrons. You can count those 6 electrons in the exponents, 2 plus 2 plus 2. And which one is carbon? A metal, a nonmetal, or a metalloid? And it is a nonmetal. Let's try another review question. So questions 1, 2, and 3. Go ahead and stop the video, see if you can answer these, and then we'll be back with the answers. Okay, we're back. What is the oxidation number of magnesium? It is an alkaline earth metal, so it's a +2. The boron family ends in what electron configuration? The boron family ends in p1. It's a p1 family. And what is the oxidation number of this? So it ends in p5, so this would be a halogen. And the oxidation number of halogens are -1. All right, let's come to atom size. So atom size is measured through the radius, and here we have a chart that is measuring the radius versus the atomic number. So looking at the atomic number, which atom is the smallest? So the smallest radius would be this little green second one right here. So that would be the element helium. So helium is the smallest atom. And then let's look at the trend. So hydrogen's a little bit bigger, helium's a little bit smaller. And then we go to the second row on the periodic table. So lithium is right here. Lithium is the biggest of that row. And when I get all the way down to neon, we see that it is smaller. So what's happening as I go across a period or a row? So as I go across a period, you see that generally the atomic radius or the size decreases. So a good way to remember this is that the smallest element is helium. And this is showing, it doesn't show all the elements, it just shows the main group elements. So you would have those transition metals right in here. But we see that helium is the smallest atom. And then looking here on this chart, what is the largest atom? So the largest atom on this chart is cesium, Cs, and they don't go and show francium, but francium you would predict that it is the largest atom as far as the radius size. So we can see the trend. So as we go across the periodic table, we see the size decreases. It gets smaller because we're getting closer to helium. And as I go down a family, we see that it increases because it's getting closer to francium. And there's a reason why for this. So as we go down a family, the size increases, and that is because the shielding effect increases. So as electrons are added to each energy level, the inner electrons block the nucleus's pull on the valence electrons or the outer electrons. And so as a result, the atom kind of puffs out a little bit. Okay, so we get francium with just one valence electron, and it's very, very loosely held. Lots and lots of shielding effect with francium. And so as a result, this is very highly reactive. Now, as we go across the period, how come the atom gets smaller? Well, that's because as I go across a period, I'm adding one proton as I go from element to the next element to the next element. But along with that proton, I'm also adding one electron. So we get a greater nuclear pull because there's more protons in that energy level. So remember, each row represents an energy level or an energy shell. And so as I go across the row or across the period, you are going to get more nuclear charge. So the nucleus is going to pull in those electrons tighter, so resulting in your noble gases being the smallest atom in that period. Let's look at ion size. So remember, ions mean that electrons have been gained or lost. So the number of protons doesn't change, just the number of electrons. And it's the valence electrons that are being lost or gained. So let's look at metals or our cations. So this is what cations do. So cations, when it's going from the atom to the ion, what happens to the size? So we see that the radius is decreasing. And that is because there are less electrons and the nucleus is still pulling on those electrons, and it's kind of like a tug of war. Well, here the nucleus is going to win because there will be more protons than electrons, and as a result, the ion size, the cation size, will be smaller than its atom. Let's look at nonmetals. So nonmetals gain electrons. What's the trend? So as I go from fluorine to fluoride ion, you can see that I've added one electron, and so now the tug of war, the nucleus is losing. So the electrons, they will kind of puff out a little bit. And so that results in larger ion size. So you can see as you add electrons, your ion gets bigger. So your anions will always be bigger than your atom. And then for your cations, as you lose electrons, then the ion will get smaller. So, and it all has to do with the nuclear charge. So with cations, it has greater nuclear charge. With your anions, it's less because there's more electrons and the protons can't pull as much. All right, so let's practice. Compare the size of the following atoms, which are the larger atom of each pair. And then compare the size of the ions. So go ahead and stop the video, and then we'll come back with the answers. Okay, we're back. So comparing the size, we have fluorine compared to chlorine. Chlorine is further down, and so as you go down, the atom size increases because we're adding an energy level. So chlorine is going to be bigger. We have carbon and we have silicon, which is the larger silicon is because it's further down. We have sodium and we have magnesium. So between the two, they're on the same row. Sodium will be larger. And then we have sodium and potassium. They're in the same family. So which one is lower? Potassium is lower. And next we have bromine and iodine. They're also in the same family. So as I go down a family, it gets bigger. So iodine is closest to the bottom, so it's the larger of the two. Okay. All right, compare the size of the following ions, which is the largest in each set. So coming here to fluorine and fluoride, your anions are always bigger than the atom, so that one's going to be bigger. And then we have potassium atom and potassium ion. The atom's going to be bigger because when it loses electrons, the nucleus is going to pull in the radius tighter. And the same thing is going to happen here because this one just lost 2 electrons. Then we have this one is gaining 2 electrons, so that's going to be larger. And then we have a series here of iron. And it doesn't matter if I've lost 1 electron or lost 2 electrons, the atom is going to be bigger.